For this ecology project, we looked into the problem of coral bleaching. Abiotic factors of coral reefs include the temperature and salinity of the water. Normal waters are between 23 and 29 Celsius and in a salinity range of 32 to 40%. Another abiotic factor would be light, as photosynthesis requires it. This limits coral growth to shallow areas. One example of a biotic factor of coral reefs would be polyps, which are tiny soft organisms with a limestone skeleton. It also includes zooanthellae, which are photosynthetic organisms that provide color to its host. A third biotic factor would be the surrounding fish and plants that are a part of the ecosystem. In the environment that corals are a part of, different levels of ecology are present. Organisms include individual starfish, jellyfish, crabs, etc. The term population can be used to describe schools of fish and corals. A community to consider would be the colonies structured by the corals as different species begin to join together. The ecosystem would be the coral reef itself, which teems with life. We also looked into symbiotic relationships within the ecosystem. The mutualistic relationship between zooanthellae and polyps is a key component because the polyps offer the algae shelter and nutrients. In return, zooanthellae supplies the polyps up to 90% of their energy through photosynthesis, aiding with metabolism, growth, and reproduction. This is important to consider because it reminds us that we have to look beyond just polyps to sustain our solution. Many human activities negatively impact the environment, creating stress factors that in turn damage coral reefs. When water temperatures increase dramatically, corals eject their algae and chlorophyll, causing them to lose their color. With the existence of global warming, reefs are faced with the threat of extinction. Additionally, pollution and oil spills introduce toxins into the water, tourism can result in people breaking off pieces of coral as souvenirs, and blast fishing destroys large pieces of coral at once. Regardless of the activity, humans have an immense impact on the health of corals. One specific example of direct human impact lies in microbeads, which are often washed down drains. This leads to pollution in the ocean by chemicals like DDT. They are eaten by smaller fish that mistake it for things like roe. These fish are then eaten by bigger fish like mackerel. The mackerel have a higher percentage of DDT as they need to consume more small fish. These mackerel in turn are then eaten by tuna. Finally, the tuna are eaten by humans. The amount of DDT found in the microbeads are amplified, increasing the amount of toxins that are consumed. This is important because it shows how coral bleaching is not the only way humans have an impact, as possible biomagnification affects the ecosystem as a whole. The solution we chose to focus on is under the category of recovery, and it is through farming practices. This includes coral IVF, larval reseeding, and fragmentation planting. Coral IVF describes the process of capturing coral eggs and sperm during spawning to cultivate coral larvae. After this is done, these new corals are relocated to small reefs. Coral fragmentation is the dissection of living corals into smaller pieces that are then stimulated to grow at a much faster rate, cloning themselves. This can combat the amount of corals that are lost. It also reestablishes the reefs, building a larger structure for the coral ecosystems. The abiotic factors would not be greatly influenced by this solution because it focuses more on recovery than prevention. This means that a coral's reaction to factors like temperature and salinity would remain the same. Although this is true, it does positively affect the biotic factors. For example, the surrounding fish would have more places to inhabit, which benefits them because it increases their opportunity for shelter and implements a more complex flow of energy. One major con to the solution is that it requires a very complex diving procedure to complete. In other words, mistakes are highly possible. Obviously, there is no way to decrease the level of complexity as everything must be exact in order for it to be successful. However, we could lessen the current chances of error by only recruiting the most qualified divers. Another problem is initial predation when the fragments are transferred to new sites. To solve this issue, we propose to improve the current approach to fragmentation by placing them in substantial clusters rather than individually. This would help them avoid predation from other marine organisms. In our research to look into existing solutions, we categorize them into 3 different approaches: prevention, building resilience, and recovery. Preventing the stress factors from occurring in the first place is very important, and solutions include agencies like the EPA that work to protect the environment. Beyond this, there are also small things that everyone can do on a daily basis to contribute to solving this issue. For example, you could use energy-efficient light bulbs to reduce greenhouse gas emissions, support brands that make products without chemicals, and reduce personal water use. And if you go scuba diving or go boating, don't touch the coral reefs and anchor in sandy areas away from corals.